So this is Geometry, Semester 1. It's the 5th unit called Pythagorean Theorem. It's the 5th lesson called Heights of Triangles Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So to model that for you, here's the website, creatormath.weebly.com. If you type that into Google, hopefully you can find this homepage. Looks like this. Remember that all of the composition book instructions, videos, everything else, deadlines are all on that homepage under that picture of the composition book. All right, we're going to go to geometry because that's where all the notes, that's where all the videos, everything else is for the comp book. Okay. For notes, videos that we're going to put with these problem sets. All right, so we're going to pass by the vocabulary. This says Vocabulary Geometry Practice Study PDF. If you're not getting 100% on your vocabulary practices, please figure out how to open this PDF and search it. All the answers are there, so you should be getting 100%. We're going to scroll to the right semester. That would be your first order of business. Here it is. Here it says Geometry Table of Contents for this semester that this lesson applies to, and it goes on pages 2 through 6 of your composition book. So you should have already copied a long time ago every line of this table of contents on the pages 2 through 6. If you haven't, stop what you're doing now and go ahead and do that. Now we're going to go down to this unit. This is the Pythagorean Theorem unit. There are 6 lessons in it, and we are on lesson number 5. So we're going right to here. We're going to open up the notes in 1 second. Here is the title, Heights of Triangles. It goes on this pages of your comp book. Please don't use this video to find the right pages, but use the actual table of contents. By the time you view this video, these most likely will be different, these page numbers, okay? So we're going to click Notes. This is what goes in your composition book. Fair warning, oftentimes I have to open it twice to get it to load. You're going to copy these into the comp book. They're going to give you examples. They're going to walk you through some examples so that when you get to the actual problem sets we're going to do next on this video, you're going to have a little bit of idea what's going on. So this is using, this is a little bit unusual to put into the unit on Pythagorean Theorem. Technically it's not Pythagorean Theorem. It is similar triangles. Similar triangles are proportional triangles, or a triangle that is smaller and a triangle that is larger, but are related to each other by a scale factor. Okay, so, and what we do is we're allowed to set up a proportion for these. The reason we cover it now is because of the right triangle connection, and we're trying to ease students into similar triangles with this one a little bit in advance of the actual lesson on similar triangles. All right, so it is under the Pythagorean Theorem unit. And let's sort of get on with this. We're going to see a lot of these same triangles, and so I might as well go ahead and explain them as we're going through the problem sets. So the assumption of you doing the problem set is you've already copied the notes into your comp book. Let's go through this. What is a proportion? So a proportion is one fraction placed equal to another fraction. This is the right answer here. Okay, so here's what I do. I draw a fraction bar equal to a fraction bar. What is a fraction bar? That is the line between the numerator and the denominator of a fraction. It's literally called a fraction bar. Okay, it literally means divided by. Okay, it literally means divided by. This is literally 1 divided by 2. That's what that line means. All right, so what would we see? We'd see one fraction placed equal to another. So let's say we had this, right? Is 1/2 equal to 3/6? Yes, of course it is. So this one is not reduced, but we know that 3/6 is the same as 1/2. This is what a proportion is. It's one fraction placed equal to another. We're going to see this play out in the problems that follow. So this says, given a person is 6 feet tall, find the height of the tree using the shadow created by the sun. So what we've tried to create here, and the sun might be in a slightly wrong place. Say the sun's here, right? And it's shining down across this tree and creating a shadow across the top of the tree. A person here is lining up where the shadow just touches the top of the person's head, comes down and ends on the ground here. So what you have is a triangle here, in fact a right triangle. Here's the smaller one, if I could redraw that. And it is nested with the same angle here into this larger right triangle, which looks like, let's say it's more like this. These two triangles are proportional to each other. In other words, the word used in geometry is similar. But here's one of my old models from class, right? If I put this down and you can try to see what this is. This is a model helicopter, a 1/43rd scale, I believe. Yeah, 1/43rd scale. It's an Augusta A109 painted in U.S. Coast Guard colors. Okay, the idea of a model or proportional or similar is the smaller triangular shape. This smaller helicopter is exactly like the real one, except that it's been reduced proportionally. So that's what's happening in a very simple way with these triangles, or these rectangles. Excuse me, these triangles. This smaller one is proportional to the large one. So if we know the sizes or lengths of these different sides of the triangle, we can then predict what it's going to be on the large one because they are related by a scale factor and in fact are proportional. And that's what we did right here. We set up a proportion, one fraction made equal to each other. That's what you get to do when that smaller shape is exactly like the bigger, related to each other by a scale factor. In this case, this is a 1/43rd scale model. All right, so a little bit off topic because there are two right triangles. That's why it ends up in this Pythagorean section. So let's see what we got here. We have a 6-foot person. Where's this problem? 6-foot person here. So we have 6 feet. It looks like this distance from the person to the end of the shadow is 10 feet. And then we have this tree here, and we're wondering how tall is the tree? It says find the height of the tree. So this becomes x. How tall is this tree right here? The tree looks like it is 30 feet to the person, who is 10 feet to the end of the shadow. So we need this total distance. We need this to be 40 feet. So the whole triangle is 40 feet here by x. The smaller one is 10 feet by 6, and you can see the smaller one here nested and here trying to pull it apart in this graphic of the two. What we can do is set up a proportion. We can make one fraction equal to another, and we can start to spell out, if we take x and put it over 40, like this, we go in the same pattern. Since we used the height of the tree, we now go to the height of the person. We put that in the numerator, and we did the distance from the end of the shadow in the denominator. So we do the distance from the end of the shadow in the denominator. These two fractions are going to be equal. This is very much like 1/2 equal to 3/6. They are two fractions that are equal to each other. And that's the brilliance of this whole exercise. And that's why we as geometry teachers get so excited about similarity and proportions and scale factors and scale models like you just saw. Any map you've ever looked at is related to the real geography that it is mapping out by a scale factor. Okay, so what do we do here? There's a procedure involved. We're going to cross multiply. I always argue to students it looks more like an x. It looks like x multiply rather than a cross. But we take 10 times x is the way this works. We separate it by an equals, and now we multiply in the other direction of the cross multiply. 40 times 6. 40 times 6. All right, so we're going to say 10x. What is 40 times 6? 240. 24 plus a 0. We're going to divide both sides by 10. Gone from this side, and x equals 240 divided by 10. The zeros disappear. It's 24. So guess what? The height of this tree is 24 feet high. Very cool, right? Very cool that we can predict the height of a tree. And of course, I'm hoping you imagine we can measure the person's height because that's accessible to us. But the height of that tree is not accessible. So by calculating it in this manner, we don't have to climb up any tree or try to drop a tape measure from the height of the tree. We can calculate the height of very, very tall things if we can set up this type of similar or proportional set of triangles. So A person 6 feet tall, what is a proportion which can be set up? So now we're going to go back through the same problem and we're going to examine it from the idea of proportion. So we said this was 6 feet. We said this whole distance here was 40. We said this was x, all right? And it looks like they're going to go through now and use, see how they're using A, B, and C, D? So here's A, here's B. This is A, B. CD is here, height of the person. They're also using BE and DE. Here's BE across here, and here's DE here. So again, if we separated those two similar or proportional triangles, there's the smaller one, and here is the larger one. Okay? So we have an AB here, and we have a BE here. Then we have a DE here, and a D and a CD here. So those are our sides. So if we set up a proportion, right, let's go through the ones they give us. They've got an A, because it says more than one answer may apply, right? We better look at all these. So AB over CD. Let's go ahead and say AB over CD. Let's write in the first one. So, and trace it out. Here's AB here, and here is CD here. So they took the heights of both and put them over each other. If that's true, we would want to take the distance to the end of the shadow of both. In this case, it is 40. Or no, we're using the letters. So BE over DE. We would want to go in the same order. BE over DE. So do they have BE over DE? Yes, they do. So this one is right. All right. Now let's map up the other one. Let's go and do it again. Let's go CD over AB. CD over AB. So CD is here, CD over AB. So now they're going the height of the person over the height of the tree. Therefore, we better go the distance to the end of the shadow of the person, DE, over the distance to the end of the shadow of the tree, BE. So I want to see DE over BE. Do I see it? Yes, I do. So this one's legal too. As long as we go in the same pattern, that proportion's legal too. Let's try the next. AB over CD. Well, we already traced AB over CD. Here it is again. And notice they flipped this. Instead of having BE over DE, they've got DE over BE. This is wrong. It can't be both. It's the one we did already. We already traced that out. And if this is CD over AB, we said is right, it looks like they've also flipped this one. The DE here is in the denominator now. That's not right. It can't be both. It's the one we already checked. So it's these two answers on this one. Right? Kind of complicated. Trace it through. Watch this video a couple times. All right? Because that's why we're trying to warm up students on similar triangles before we actually get to that unit, by the way. So here we are again. Now we're talking about setting up an actual proportion. So now we're going through the same scenario, and it says more than one answer may apply. So let's do this again. This whole thing is 40. This is 10 and 6. So we have a 10 and a 6, and the larger one, we have an X and a 40. There we go. So, and these are proportional, or similar is the word in geometry. Similar. Similar. That means proportional. I wish they didn't use that word because we say things are similar. That means they're kind of alike in our normal vernacular. But this is a very specific word in geometry, and it means proportional. So they start with X over 6. X over 6 is equal to, since we went height to height, we're going to go distance to distance in the same fashion, 40 over 10. So let's look. X over 6, 40 over 10. Check. Let's do it again. Now they went 6 to X. They went the other direction. If we're going 6 to X equals, we went from person to tree. Now we're going to go from person to tree. 10 to 40. 10 to 40. This one works too. All right, now let's just compare. I know the pattern of these answer choices, so it looks like they're going to run the same drill they just did, and I'm going to try to speed up a little bit. So X over 6 here, I need to see 40 over 10. I can't see 10 over 40. That's wrong. It's only one way, and the way we did it was right, so that one's wrong. And if this is 6 over X, I better see 10 over 40. It's 40 over 10. This is wrong. These are your two correct answer choices. So there is a problem they snuck in right here. Looks like problem number 5. They say, given the proportion x over 6, let's rewrite it, equals 40 over 10, what is the result after cross multiplying? So cross multiply looks like this. 10 times x is on one side of the equals, 6 times 40 is on the other, or 240. 10x equals 240. All right, same scenario. The sun is casting a shadow across the roof of a house, and it's touching a mailbox. How high is the mailbox? 6 foot again. So you see whether it's a person or a mailbox doesn't matter. We're probably going to find the height of the house. Yep, so x again. So they're walking us through this pretty gingerly for how complicated the topic can be. There's this smaller triangle which is proportional or similar to this larger triangle. All right. This one's x, and what's the total distance here? It looks like 40 plus 10 is 50. And this one is 6 here and 10. So let's set up a proportion. It's one fraction made equal to the other. If we go x over 6, now we go in the same direction since we went tree to mailbox. We're going to go tree distance to mailbox distance, 50 over 10. We're going to cross multiply. We're going to get 10x on one side of the equals, and 6 times 50 is 300 on the other. Whoops, I need my 10 times x. Get that in there. Divided by 10, divided by 10, x equals this, 30. So this house is 30 feet high. That's what I get. Did I do this wrong? This is 50, and I did 50 times 6 is 300. I like this one here. I'm just going to make a note of that. It should have showed up in the A position. So let's go to the next. But that is 30. They want to know the acceptable proportions. So here's the smaller, and they're using CD, C, D, and DE, and DE. So we're going to rearrange, just redraw our proportional triangles, and relabel them. This is A, B, and out to E. All right, so they're going to start with, the first one here is AB over CD. So AB over CD equals what? AB over CD. We went house to mailbox. So now we're going to go house distance to mailbox distance. BE to DE. BE to DE. BE to DE. Check. Next, they give us CD over AB. They want to know what proportion that matches up with. So let's track it through. CD over AB. So they're going mailbox to house, so now we're going to go back to mailbox to house. We're going to say DE to BE. Same direction. The direction they went in, we repeat. DE to BE. And sure enough, that's what it is here. So it looks like, and if you noticed, if you flip these here, it flips. So they went, this is AB to CD, we went CD to AB, it flips this here. You can flip both sides of this thing just like that. You can literally flip both fractions. As long as you do both, it's legal. Now here's what they did here. They said DE over BE. This can't be legal because we already said it was BE over DE. And this one here we said was DE over BE, so it can't be BE over DE, right? Kind of hard to say and maybe hard to figure out. Take your time, pause the video, and walk through it. Let's keep going. There we go. Now they want a proportion. So for us, we've got an x here. We've got a total length of 50. And we've got a 6 and a 10. So here's what we start out with. X over 5 equals what? If you go x over 5, so I want to see this x over 6 here. Okay, those will be changed by the time you see this. I want to have x over 6 here. If x over 6, then I'm going to have 50 over 10. I want house to mailbox. Now I go house to mailbox. 50 over 10. This one here is legal. Okay. Then they also they flip it, 6 over x, and I already know I can flip this. I can already go 10 over 50. We're knowing what we know about proportions now. We can flip those. If you flip this one here and you flip that one there, that's legal. This is still legal. So 10 over 50. However, here where they say x over 6 is 10 over 50, no, can't be that either. 6 over x cannot be 50 over 10. We know it's 10 over 50. So you're going to see a you're going to see a pattern on these problem sets. The point is to allow you time to think through what's happening. So now they're giving us x over 5 here equals 50 over 10. If we cross multiply, what do we get? 10 times x is 10x equals 5 times 50 is 250. So 10x equals 250. And then this could be solved again by dividing both sides by 10. And then we would get x equal 25 if we went all the way to the end. They just want to know what's the result after cross multiplying, an intermediate step of the solution. All right, here we have a truck. How tall is a truck? 4 feet. This truck is 4 feet tall. So we have this right triangle here. That's 4 by 1. Okay, and I don't know if I can say 1. It's 4 high and 1 from the end of the shadow. Then we have this larger triangle here that represents the height of the building. It's this distance, which is 11 plus 1 is 12. It's x high and 12 from the distance to the end of the shadow, right? So they want us to set this up. Let's set up a proportion. Now let's go in a little bit different pattern than we did before, just to show how versatile these proportions are. Let's do 4 over 1. If we went height of the truck over distance to the end of the shadow, 4 over 1, then we go height of the building over the distance to the end of the shadow of the building, x over 12. And you're going to see, we're going to cross multiply, 1 times x is x, and 4 times 12 is 48. This building's 48 feet high. So notice we did a different pattern before, but as long as we stayed consistent. We went 4 to 1, so we got to go x to 12. Notice the similarity of that pattern. As long as we stay consistent when filling in our proportion, this proportion is going to work. Now they're going to quiz us from another perspective, and this doesn't all fit in. Let's see what we can get to fit in here. So we've got the smaller right triangle here, which is CD and DE. C, D, D, E. And now I'm going to draw this where we can hopefully still see the same thing, all of it. Can I see it all? These are similar or proportional. And this is AB here, and out to E here, the end of where that shadow ends or terminates, right? E. So let's start with what they've got. They've got an AB over CD. We want to know what it equals. So they went AB over CD. So height of the building, height of the truck, distance of the building to the end of the shadow, distance of the truck to the end of the shadow, BE over DE. BE over DE. BE over DE. Check. This one's right. Now they give us CD over AB, and what we know now, we can actually do this quicker. Because they flipped this fraction, if we just flip this one, we're going to already know the answer to this. So if we flipped the AB to the bottom, the CD to the top, then the DE is going to come to the top here, and the BE is going to go to the bottom here. And of course, I'm talking about the numerator and denominator positions, but just saying top and bottom maybe is slightly bit easier at the moment. So if this is CD over AB, and that's DE over BE, this is correct too. And let's just trace it out. Let's go CD over AB. Here's CD over AB, CD, AB. So we went truck to building. Now we're going to go truck to building. DE over BE, DE over BE, check. All right, so we're now going to look at these down here. We've already figured out that these are accurate. So if you tell me AB over CD again and it's different over here, see how they flipped it? They flipped one side but not the other. Nope, illegal. Same with CD over AB. They flipped one side here but not the other. Illegal, does not work anymore. All right, same problem. We've got 4 foot high, 1 foot from the end of the shadow. We've got 12 foot from the end of the shadow, and x high. So we're going to do an x over. Let's do x over 12. If we go that direction, we're now going to do 4 over 1. So whatever pattern you took on the first one, we went x to 12. Now we're going to go 4 to 1. Notice the same pattern. We went height to the length of the shadow, and then we put it equal to height to the length of the shadow, as long as they are similar triangles, which they are, which means proportional. Just like that model helicopter I showed you, we can now blow it up to the original size. We can cross multiply. Oh, they don't even ask us this. Oh, I'm kind of going a different direction here. Let me slow down a little. Let's do x over 4. Let's check theirs. Let's go x over 4. So if x over 4 went height to height, now we're going to go distance to distance. So this is going to be 12 over 1. Check. 12 over 1. Then they flipped it. 4 over x. We already know that this is going to be 1 over 12. You flip one side, you must flip the other. So 4 over x. 1 over 12. X over 4, 12 over 1. Let me slow down a little here. X over 4 is x over 4. Then we're going to do 12 over 1. X over 4 is 12 over 1. Okay, I don't know why I'm getting messed up here. We flip this, 4 over x. This still says 12 over 1. I don't like this. It's not this one. It's 1 over 12. There we go. It's that one. All right? And this would be 4 over x, 12 over 1, out. All right? So, these two. Look closely when you're doing it, because you see even I'm getting mixed up on it, right? Given the following, how do you cross multiply, or what happens when you do, or what's the next step? 12 over 1. Cross multiply, which looks more like an x, I would argue. 1 times x is x equals 4 times 12 is 48. Right? All right, make sure you're matching up the title to this. This is Geometry Semester 1. It's the 5th unit called Pythagorean Theorem. It's the 5th lesson called Heights of Triangles Practice. It's on creatormath.com under the Geometry tab. Hope this helps.